The F-4E simulation can be played in two quite different modes, as the Phantom is a two-crew aircraft. For single-player mode, Heat Blur has provided an artificial weapon systems officer to be your crew, while you take on the role of pilot. While for multiplayer mode you can select which crew position you want to take, provided that the pilot takes his seat first and afterwards the WSO can take the rear seat. A training mission for the WSO presents the challenge that the training facility of DCS is meant only for single-player mode, and the only solution is to pretend that you do have a pilot seated first on the aircraft, when in reality you will sometimes have to move forward to the pilot seat to accomplish some of his functions. Unfortunately, Heat Blur has not provided an artificial pilot for this simulation. For this training mission, we will employ ground electric power and 2 solid propellant cartridges. While it is also possible to do the cold start employing the aircraft's electric battery and/or an external pneumatic air source, we will not use that option on this mission. Press spacebar to begin the training. We will begin this cold start procedure with the steps for the rear cockpit, from the Before Electrical Power section of the F-4E normal procedures. Put on the helmet that is over the right canopy rail by clicking on it. It is a bit dark at this hour. If you can't find a cockpit element, feel free to employ your flashlight, which can be toggled with left Alt+L. Another way to illuminate the cockpit at cold start is the cockpit white floodlights. They are connected directly to the battery bus, so they can be used even on a cold aircraft, but do not leave them on too long to prevent draining the battery. Finding the switch in the dark can be difficult, so you may want to assign a keyboard binding to it. On my case I employ left Control F. Also, if the air traffic noise prevents you from hearing me clearly, you can close the canopy at any moment, as it is pneumatically operated and does not need electric power. Press spacebar to continue. We will continue the steps of the Before Electrical Power procedure, following a left to right cockpit sweep. UHF radio, off. The communication control panel provides selection and mode of the UHF radios in the aircraft. Check that the COM function selector knob is currently at off. Press spacebar to continue the sweep. Countermeasures cockpit control unit, off. The WSO can use this panel to select the different modes of operation of the CM system. For now, check that chaff and flare modes are off, and the ripple switch, under the yellow guard, is also off. Throttle levers, off. The rear cockpit throttles are linked to the front cockpit throttles, such that only the pilot can start the engines or move the throttles into the afterburner thrust range. The throttles can be retarded from max to idle from the rear cockpit, although the off position must be selected from the front cockpit. Press spacebar once you confirm both throttles are at off. Radar power, off. This knob controls the power state of the APQ-120 radar, for now keep it at off. AVTR switch, off. This switch controls the airborne videotape recorder system, which records the intercom sound as well as the rear radar screen. Digital Scan Converter Group, DSCG, display mode knob, off. The DSCG displays radar, weapon, and targeting pod video footage. Its glare shield cover can be removed by clicking on it. ECM equipment, off, since its use on the ground could endanger personnel. The WSO's ECM panel controls the electronic countermeasurement and jamming system of the aircraft. The left panel is connected to any pods carried on left wing stations, while the right panel controls stations on the right wing. Interpretation of the modes, techniques, and exact operation of the lights depend on the loaded jammer model, and we will study those on a future dedicated ECM training mission. INS equipment, off. Check that the inertial navigation system is currently off. Nuclear store consent switch, safe. Used to arm nuclear stores, in the safe position release is inhibited. REL allows releasing stores unarmed, while REL arm allows dropping nuclear stores armed. Press spacebar once you have confirmed it is set to safe. Navigation computer, off. The navigation computer control panel serves as an interface for managing the aircraft's navigation, including its position and targets for navigation instruments like the HSI and BDHI. It can operate in two modes, inertial and air data. Press spacebar once you have confirmed it is set to off. Battery bypass switch, off. When toggled on, it de-energizes the battery relay, disconnecting the battery from the essential 28-volt DC bus and ceasing charging. Particularly used in suspected cases of thermal runaway. Circuit breaker panels, check all in. Unfortunately, the rear cockpit circuit breakers are not yet simulated. We have completed the before electrical power checks. At this point, the WSO would wait for the pilot to either connect the battery bus, or ask the ground crew to connect a ground power unit. Since we currently don't have a real pilot available, this instructor will perform the necessary steps. First, I will connect the battery bus on the front cockpit. This step is non-essential, but I like to communicate with ground crew using the intercom rather than hand signals. Next, I will ask ground crew to connect the power unit. Press spacebar once the crew chief reports that it is connected.
Alright, external power is connected.
Good, now I will set the generator switches to external on. Next, we will perform the after electrical power procedure. Instrument ground power switch, set to test. In the test position, it connects external electrical power to the instrument buses, contingent upon the generator switches being set to external on. This can be used during a cold start after applying ground power and before starting the engines, to already set up the aircraft and operate some systems that require power on these buses. Navigation computer, set. We will study the Phantom's navigation computer in detail on a dedicated training mission. For now we will see just how the system is set up during the cold start. Function select knob, standby. This powers up the computer, but the latitude and longitude position integration is inactive. Wind counters, set pre-flight wind direction and speed. The highlighted knobs enable manual setting of wind velocity, in knots, and direction, in degrees, from, as displayed on the adjacent counters. These values are used by the navigation computer in air data mode. Note that on DCS, to facilitate gameplay the correct wind values have been already entered. You can also corroborate the wind at the mission briefing, with left Alt plus B. Variation counter, set local magnetic variation. This knob allows manual setting of magnetic variation, in degrees. Essential for navigation computations in air data mode, and for initial, BAF, INS alignment. Just like the wind, on DCS the magnetic variation is already correct for the mission. Position update switch, norm. This 3-position switch is used for making navigation fixes, to correct INS drift by overflying a known geographical location. Present position counters, set. These knobs are used to manually change the current aircraft position in terms of latitude and longitude, as displayed on the adjacent counters, in degrees and minutes. The present position coordinates must be set as a prerequisite to aligning the INS. The mission start position is displayed on the knee board, which you can display with right shift plus K, but to facilitate gameplay on DCS the correct position is already set. Press spacebar to continue once you have checked that the present position is correct. Target counters, set for target 2. The positions of the mode knob are named very confusingly. TGT1, TGT2 and reset, sound as if you could store 2 waypoints and perhaps reset that, but that is not the case, as this is a very primitive navigation computer which can store in its memory just a single waypoint. So let me provide perhaps better names. TGT1, current panel coordinates. This position will navigate towards whatever coordinates are currently visible or entered on the panel. That's it, no memory whatsoever, just plain navigation towards the coordinates currently on the panel. TGT2, memorized coordinates. This navigates towards coordinates that you have memorized in the computer. The memorization is done by first putting the coordinates on the panel, and then moving the mode knob to the spring-loaded reset position. Reset essentially means load these coordinates into the memory. So, now you can either select TGT1 for the current panel coordinates, or TGT2 for memorized coordinates, and then the HSI will provide the heading and distance to the selected point. Press spacebar to continue. All this long-winded explanation is because you will now enter first the coordinates of waypoint 2 of our flight plan, to have them memorized, before entering those of waypoint 1. First, call up the kneeboard, with right shift plus K, and page forward until you reach the turnpoints page, where you can check each waypoint coordinates. Now, turn the highlighted knob, until its adjacent counter shows the waypoint 2 latitude, 68 degrees, 1 minute north. OK, now continue with its longitude, 20 degrees, 38 minutes east. Good, now that you have the correct coordinates on the target counters, store them on the computer memory with the next step. Function selector knob, reset. Moving the knob to reset clears any previously memorized coordinates. Next, moving the knob from reset to any other position causes the coordinates shown on the target counters to be memorized. Function selector knob, standby. Now, the function selector knob must be placed in standby, in anticipation of aligning the INS. Target counters, set for TGT1. Next you will enter the coordinates of waypoint 1 on the target counters. Turn the highlighted knob, until its adjacent counter shows the waypoint 1 latitude, 68 degrees, 27 minutes north. OK, now continue with its longitude, 17 degrees 17 minutes east. Good, you now have the waypoint 1 coordinates on the target counters, and you will be able to fly to this first waypoint by selecting TGT1 on the mode knob. Once you overfly this waypoint 1, you will be able to instantly select the second waypoint just by selecting TGT2. While flying to this second waypoint, you will be able to enter coordinates for a third waypoint, and after overflying waypoint 2 the function knob would be positioned to reset, then back to TGT2, now pulling the waypoint 3 values from the target control values. Press spacebar to continue. INS alignment, as desired. The Phantoms and ASN 63 Inertial Navigation Set, INS, provides real-time accurate positional, velocity, attitude, and heading information. It is a self-contained, fully automatic unit which uses a gyro-stabilized inertial platform upon which are mounted 3 sensitive accelerometers. On cold start, the INS must undergo an alignment process, where the sensitive axis of each accelerometer is aligned through interaction of the accelerometers and gyros. One is aligned to the north-south axis, one to the east-west axis, and one to the vertical axis. Once aligned and with the platform stabilized in pitch and roll by its gyros, and oriented to true north, the accelerometers will sense acceleration in any direction. This acceleration is integrated by a computer to produce velocity, ground speed, course, and distance traveled, which are used by the aircraft's navigation computer to drive the navigation cues for the HSI. Press spacebar to continue. The INS has 3 modes of alignment on aircraft start, from which you can choose BATH, heading memory, and gyro compass full alignment. BATH, best available true heading. This alignment produces a lesser navigation precision, but it only requires a little over 2 minutes to align. Heading memory. This alignment takes the same time as BATH but afford much higher navigation precision. It is available only if the aircraft has not been moved from its last powered location, which is the case for our current aircraft. Gyro compass alignment provides the maximum navigation precision, but it takes around 8 minutes to align. For this mission we suggest performing a heading memory alignment, to save training time. Press spacebar to choose a heading memory alignment, or press backspace to choose a different alignment type. OK, you have chosen to learn one of the remaining alignment types. Press spacebar to select a gyro compass full alignment, or press backspace to choose a BATH alignment type. Prior to performing any alignment, the standby reference system must be selected. On the front cockpit, the navigation computer control panel should be turned to standby, and its position update switch should be selected to normal. Local magnetic variation should be entered on the variation counter, and the position counter should be set to local latitude and longitude. I will now go onto the front cockpit and ensure that the reference switch is set to standby. All the other prerequisites have already been ensured on the prior steps of our cold start. Press spacebar to continue. INS alignment mode, check it set to Euro compass. For a BAF alignment, this switch must be set to its aft position, Euro compass. On DCS by default it is already on that position, except if the aircraft has stored alignment data, on which case it will default to its forward position, heading memory. INS power knob, set to standby. For this alignment type, the standby position must be selected momentarily, to avoid an INS no-go. INS power knob, set to align. After a moment at standby, turn the knob to align, the heat light may be ignored. The INS will begin its BAF alignment, wait for the green align light to illuminate steadily. If you want, you can accelerate time with left control plus Z. I will return time to normal as soon as the align light illuminates. The align green light is on. Instead of waiting for the light to flash, place the power control knob to nav. Since the set was not allowed to complete Euro compass alignment, precise alignment with true north, the accuracy of the INS is reduced. INS lights, out. Press spacebar, after checking both INS lamps are off. The INS alignment has been completed. This finishes the after electrical power section of the cold start procedure. Press spacebar to initiate the rear cockpit interior check. Rudder pedals, adjust, with crank on front pedestal. On DCS this is just an animation, for immersion purposes. You can click on the flight stick space to hide the stick, for an easier view of the crank handle. Ejection seat height, adjust as desired. The ejection seat may be adjusted vertically only, by actuating a momentary contact switch on the right forward side of the seat. Left click to raise, right click to lower. The seat can be adjusted through a total distance of 6 inches. Communications and navigation control panel, set. This panel provides selection and control of both the UHF radio and the TAC and navigation systems of the aircraft, and it is duplicated in both cockpits. COM function selector knob, TR plus G. This knob powers up the radio and determines the current configuration of the COM receiver transmitter of the radio system. On this mission, set it to transmit receive plus guard. Communication channel control knob, as required. Preset manual switch, set to preset. Communication volume control knob, as desired. For this mission, select preset COM channel 2, for contact with Bodo air traffic control. Auxiliary channel, and auxiliary volume control knobs, both as desired. These controls are used to access 20 common preset channels that cannot be changed in the cockpit, used with the receive-only auxiliary component of the UHF radio. Press spacebar to continue. On the TAC and control panel, set. Navigation channel control knobs, as required. Navigation volume control knob, as desired. TAC and function selector knob, transmit receive, TR. The TACAN panel is duplicated in both cockpits, and for this mission set it to channel 47 X-ray, for the Banak TACAN station. Communication command button, as desired. Control over the radio is determined through pushing the COM command button in the respective seat. The button will illuminate green in the cockpit which has the control. The button lamp brightness can be adjusted by rotating it. Navigation command button, as desired. In the same fashion, the nav button dictates which seat has control of the TACAN settings. Its button will also illuminate green on the panel of the cockpit that has command of the system. Each press of these buttons will toggle which crew is in command of the system. For this training mission, the rear cockpit should have the control, so press both command buttons until both lights are green. VOR, ILS, and marker beacon volume, as desired. The volume control consists of two knobs. The square knob adjusts VOR and localizer audio, while the round knob controls the marker beacon audio. Press spacebar to continue. Oxygen quantity gauge, check. The oxygen quantity gauge has a range from 0 to 10 liters. Check that the current quantity is sufficient for the intended mission, and the off flag on the gauge face is not visible. On the front cockpit, its oxygen gauge has a test button that checks the operation of both front and rear gauges. I will now press and hold it down, as the pilot would do. During this test, both cockpit gauge needles should rotate from the current oxygen quantity indication, down to an indication of 0 within 15 seconds. I will now release the test button. Both gauge pointers should return to the original indication of current oxygen quantity. Press spacebar to continue. Emergency flaps slats handle, forward. Emergency extension of the slats flaps, in case of no hydraulic power, is accomplished pneumatically by high-pressure air from an emergency air storage bottle, when pulling either emergency flap extension handle aft. The air bottle contains sufficient air for only one extension. Intercom control panel, set. Intercommunications between the aircrew and with the ground crew is provided by the intercom system. Volume control, as desired. The input level of the intercom signals to the headsets is adjusted with this knob. Signals received from other radio receivers are not affected. Amplifier selector knob, norm. Each cockpit is provided with a primary and secondary amplifier. If a primary amplifier becomes inoperative, communications may be restored by selecting the secondary amplifier with the backup or emergency positions of this knob. Function selector switch, set to hot mic. The hot mic position allows automatic operation of the intercom. Cold mic is for manual intercom use, with the crew needing to switch the microphone button on the throttle to its ICS position to talk. The radio override position is identical to hot mic, except that other radio communications are reduced in volume. Oxygen supply system, check and set. On the Phantom, breathing oxygen is supplied by a 10-liter liquid oxygen system. The system consists of a converter, a coil to convert from liquid to gaseous oxygen, and a console-mounted pressure demand regulator in each cockpit. The regulator automatically controls the pressure and rate of flow of oxygen based on demand and altitude. It provides a proper mixture of air and oxygen at low altitudes, and pressure oxygen at high altitudes. Oxygen supply lever, fully on. This lever controls the oxygen flow, on or off, from the regulator. Diluter lever, normal. This lever controls the mixture of air and oxygen. For a proportional amount of air to oxygen, the normal position should be selected. For only oxygen, the 100% oxygen position is used. Emergency lever, normal. Usually set to normal, the emergency position provides continuous air pressure to the face mask for emergency use. The test mask position provides positive pressure to test the face mask for leaks. Check the oxygen pressure gauge. The oxygen system pressure should indicate between 50 and 125 psi, until the converter is depleted. Put mask on and hold the emergency lever in its test mask position. Breathe normally and check flow indicator operation. A white indicator indicates flow due to a leak that must be corrected before flight. Return the emergency lever to normal. Good. This finishes the checking of the oxygen regulator. Press spacebar to continue. Emergency gear handle, in and secure. Deploys the landing gear using a pair of compressed air bottles. The handle cannot retract the gear, only deploy in an emergency. Press spacebar to continue. Emergency brake control handle, in and secure. Pulling the emergency brake handle in either cockpit discharges the brake system hydraulic accumulator, providing emergency braking to the brake pedals, with normal feel but with a limited number of applications. Because of this limited number of applications, taxiing should not be attempted when using the emergency brakes. Gear position indicators, gear down indication. Check the landing gear status, it is noted with the word up, a barber pole illustration when in transition, or the icon of a wheel, when down. Slats and flaps position indicators, in and up indications. For the slats, their status is noted with the words in or out. For the flaps, their status is noted with the word up, flaps up, or DN, flaps down. When transitioning, it may show a barber pole indication. When transitioning back to the up position, the indicator does not change until the flaps are fully retracted. Press spacebar to continue. Canopy emergency jettison handle, forward. The canopies are jettisoned by compressed air supplied from the basic pneumatic system to two independent canopy jettison systems, one for each cockpit. Canopy jettison takes place on three situations: when the crew ejection seat is fired, when the emergency canopy jettison handle is pulled by either crew to get out of the aircraft after a forced landing, or when the external canopy jettison handle is actuated by rescuers. Attitude indicator, check and set. The AJB-7 azimuth reference system provides attitude information to the attitude indicator of the rear cockpit instrument panel, regardless of the reference system selector switch position. A trim knob provides the ability to adjust the attitude sphere to reference the aircraft correctly. Should power be disconnected from the indicator or the AHRS, the off flag will display. Rotate its pitch trim knob to check travel, -10 to +8 degrees minimum. Then, set horizon bar level with miniature aircraft. Press spacebar to continue. Clock, wind, and set. A clock is provided for the WSO, including a stopwatch function. The clock time is set with the highlighted knob, however on DCS it is already set to the mission's start time. The stopwatch is started, stopped and reset by successively pressing the top right button. Accelerometer, reset to 1G by pressing its knob. The indicator has three movable pointers, one for current G load, while the other two record the maximum positive and negative G load attained. Navigation mode selector switch, as desired. Selects the navigation source that will be used for the needles of the bearing, distance, and heading indicator, BDHI, as shown on the table at left. Press spacebar to continue. RWR systems, check as required, then off. Press the system power button to turn on the ALR-46 radar warning receiver. When pressed, the RWR control panel and its display will go through a warm-up, with the illuminated buttons flashing. The ALR-46 radar warning receiver, or simply RWR, is our passive defensive system for detection of airborne and surface-to-air radar threats. It receives signals from multiple antennas installed at the aft of the fuselage, on each wingtip and under the nose, which are used by the system to determine a bearing to the emitting radar. Further processing of the signal against a stored threat catalog ascertains emitter type, as well as relative threat range. The resulting process threat signal is then presented on the RWR CRT display, with bearing to the emitter shown on the display with the top relative to the nose, 12 o'clock, and the bottom to the tail, 6 o'clock, and with proximity to center relative to the system's calculation of the level of threat, with closer indications being of higher danger. In normal operation, the RWR can display 16 threats concurrently. Once the RWR is warmed up, its lights have stopped flashing, press its SYS test button to initiate a self-test. The test provides a 3-band check, 1 low, 2 mid, 3 high, in all 4 quadrants for proper sensitivity, along with an angle confirmation of 225-degree relative bearing for diagnostic purposes. Turn both knobs to adjust the RWR display brightness and the audio level of its warning sound. Once the test finishes, turn off the RWR. KY28 power selector knob, off. The KY28 is a speech security unit, which can be used with both the UHF and intercom systems, to either cipher outgoing voice transmissions, or decipher received voice transmissions. However, these functions cannot be performed simultaneously. The KY28 is not powered in the off position. It is powered in the on and relay positions. Relay would provide the ability to use the KY28 as a retransmission facility, which is not modeled in DCS. KY28 mode selector, P. The mode switch can be set to either operating mode plain, P, or cipher, C. Press spacebar to continue. Canopy manual unlock handle, forward. The manual unlock handle is used in the event of pneumatic system failure. The handle, when pulled aft, unlocks the canopy so that it may be pushed open. Before manual unlocking of the canopy, the normal control lever must be placed in the open position. Stall oral tone, as required. The round stall warning knob controls the volume of the angle of attack tones that sound when flying at certain angles. Under certain conditions, the system can override the volume to ensure the cue is always audible in dangerous situations. The top square knob controls the voice low altitude warning, which is a system not fitted to our F-4E variant. Press spacebar to continue. Cockpit lights control panel, as required. White floodlight switch, off. This switch activates a separate emergency floodlight, also called thunderstorm light, that illuminates the cockpit in white. It is connected directly to the battery, so you can use it on a cold and dark cockpit to quickly illuminate the whole cockpit. Instrument panel lights control knob, as required. This knob adjusts the background illumination of the instrument panel, as well as edge lighting for most of its gauges. However, the main flight instruments are controlled by the pilot via the flight instrument brightness knob instead. Console lights control knob, as required. Ranges from off to brightest, and adjusts the illumination level for the left and right console. Standby compass light switch, as required. This switch illuminates the light for the standby compass, but it is not yet implemented on DCS. Console floodlight switch, as required. It controls the lighting level of red floodlights for the consoles. 3 settings are available: dim, medium, and bright. To turn them off, place the switch in dim and the console knob in off. Floodlights for the instrument panel are controlled by the pilot. Indexer lights control knob, as required. Adjusts the illumination of the angle of attack indexer lights to the left and right of the canopy bow. Press spacebar to continue. Warning and indicator lights, test. The warning light test switch allows you to confirm function of the various emergency indicators in the cockpit. Intercom system, check with help from the crew chief. Press A to call up the crew chief menu, then select crew chief, and then comms check. Press spacebar once the crew acknowledges. Use a long press of A to dismiss the circular menu.
Loud and clear.
Good, this completes the rear cockpit interior check. Press spacebar and I will proceed to start both engines. Seat pins, check removed and stowed. Both ejection seats are fitted with safety interlock pins to prevent unwanted ejection while the aircraft was still being serviced on the ground. At this point on the procedure, the simulated ground crew will automatically remove them, so the seats are now armed and able to eject. Fore and aft area, clear. Ensure the wheels are chocked, the engine intake and exhaust areas, the starter exhaust areas, and both cockpit and canopy rail areas are clear of personnel and equipment. Fire guard, posted. Check that the fire extinguishers are being manned by the ground crew. Throttles, off. Double check that both throttles are on their off position. This completes as we still have ground electric power connected, we can employ the UHF radio to contact air traffic control. Check that the radio is set up properly. COM channel knob should be set to preset 2 for BODO ATC, and the preset manual switch at preset. COM mode knob, confirm it's set to transmit receive or TR plus guard for voice communication. COM CMD button, make sure that your cockpit has command of the radio, its light should be lit green. On your HOTAS throttle, set the mic switch forward to transmit over the radio. The mic switch back is for transmission with the intercom. The DCS communications menu should appear. Its top line identifies which radio device you are using. On this case it's the UHF ARC-164 radio. Select F5, ATC. F1, BODO. F3, request startup. Press spacebar once ATC has cleared you for startup and press F12 to clear the menu.
Enfield 1, cleared for startup, wind 084, at 6 meters per second.
We are now ready to start the engines. For this mission we will employ starting cartridges instead of ground air. Next, I will ask ground crew to load starting cartridges. Press spacebar once the crew chief reports that they are loaded.
Cart's loaded, sir.
Good, now I will start the right engine. Okay, now I will start the left engine. With both engines running, I will now enable both generators. External electrical power, disconnect. Now that we have both generators online, I will ask ground crew to disconnect the electric power. Press spacebar once you hear the crew chief confirming that external power has been disconnected.
Yes, sir. External power is disconnected.
Now that both engines have started, and the aircraft is generating its own electric power, we will perform the procedure steps needed before taxi. Communication and navigation equipment, on and check. TACAN, confirm it is already on, set to transmit receive, and tune to station 47 X-ray, for our destination, Banak Air Base. UHF radio, check it is set to transmit receive plus guard, and tune for today's mission, preset number 2, for BODO ATC. Press spacebar to continue, target designator, power on and stow. The PAVE Spike targeting pod entered service in 1974 and provides a slewable TV image for spotting ground targets. It can also fire a laser for determining range information and to provide guidance for laser-guided weapons. The target designator control set panel allows you to interact with the PAVE Spike targeting pod. The highlighted button turns it on. Whenever this pod is equipped, power to the system should be provided even if not using it, as its stowed position is held electrically only, and without power the pod's camera head swings freely and can get damaged when forcefully bumped into its gimbal limits. As simulated on DCS, the pod is automatically turned on when the aircraft is electrically powered, but for this training lesson I have left it off so that you can manually power it up. Alternating presses of the stow button will unstow or stow the pave spike pod head, an operation that takes about 5 seconds. The head is stowed when the button is illuminated. In the stowed position, the camera is rotated upwards and a cover is moved in front of it. This protects the camera from stones and other hazards during taxi, takeoff, or low-level flight. As simulated on DCS, the pod is automatically stowed when it is powered on or off. That's why the power on light can take 5 seconds to extinguish if you power off the pod when its camera is unstowed. Make sure the stow light is on, then press spacebar to continue. Good, the pod's camera is now stowed. Next, please select spacebar if you want to perform the target designator bit tests. Backspace if you'd rather skip them. The pod has 5 built-in tests, with bit 1 being the actual mode used during normal operation. They can be activated and switched through by clicking the bit button below the display. The Go and MAF lights show the result of the bit Go for a successful test, MAF for a malfunction detected. During normal operation, activated through bit 1, neither of the lights are illuminated. Press the bit button until it displays a 0. The bit 0 is basically a lamp test. When selected, all lights on the panel illuminate with full brightness, so you can visually check if there is any burn bulb. When bit 0 is active, none of the lighted buttons work. You should advance into bit 1 in order to exit this test mode. Do it now. Press the bit button until its visor displays a 1. On bit 1, all the pod circuits are energized and monitored. If any voltage reading is abnormal, the MAF lamp will illuminate. Go does not illuminate in this mode. This is the standard operational mode. The pod can be used normally and the system will continuously monitor its status. The next bit requires the pod to be unstowed. Do it now. Good. Now press the bit button until it displays a 2. On bit 2, the pod simulates tracking functionality, simulating all inputs, altitude, and range data. After about 15 seconds, the test is finished with either Go or MAF illuminating. For the test to be successful, the aircraft must not be moving, the pod must be unstowed and INS must be integrated. The Go light is lit, indicating a successful bit. We will now prepare the requirements for the next bit, which tests the pod's laser. First, to employ the laser, a valid code must be entered on the laser coder control panel. 1688 is already preset. Transfer this code to the pod by pressing the enter button. Make sure that the no-go light does not remain illuminated. Good. Now use the video select button that alternates between weapon cameras, such as the one of a Maverick TV missile, and the camera of the ASQ-153 targeting pod. For this bit, select the latter. Next, set the DSCG display mode to TV to display the pod's camera feed. You may use the highlighted knobs to adjust the display brightness and contrast. Press spacebar to continue. For the bit 3 test, the pod should be unstowed, which on this case it already is, as denoted by its button light being off. Finally, press the laser ready button just once. The button will not illuminate, as we are on the ground. We are now ready to perform the test. Press the bit button until it displays a 3. Bit 3 tests the laser energy level. The pod's head moves to a special position where it looks inside itself, such that the laser fires against a special sensor mounted inside the pod. Once the pod has reached the test position, the Go light will illuminate. The test position has been reached. Now you must press and hold the reject override button to start firing the laser. When the laser fires, a 5-second test program starts, with the special sensor measuring the laser energy. The Go lamp illuminates to indicate that the laser energy level is above the required minimum. For the last bit test, press the bit button until it displays a 4. On this test, the pod simulates a laser slant range of 2100 feet to test the ranging computations of the system. On the front cockpit, the pilot can assist the test by confirming the range indicator readout. The Go lamp illuminates to indicate a successful bit. Press spacebar to continue. All the bit tests are completed. Now you can stow the pod and leave it on bit 1. We will learn more about the targeting pod use on a future dedicated training mission. Radar bit checks, initiate. The Westinghouse AN/APQ-120 Fire Control Radar is a solid-state pulse radar providing the F-4E with air-to-air intercept functionality, air-to-ground mapping, ground target reference provision to the labs and WRCS bombing systems, as well as radar beacon capability. Starting with production of the F-4E Block 60, the Digital Scan Converter Group, DSCG, display was introduced, which increased the overall ease of handling the radar by adding additional information on the display directly, including current radar range setting and the calculated range rate value against the current acquired target. The DSCG provided the ability of the 2 crew members to utilize the displays independently. With it, the pilot could utilize TV air-to-ground weapons while the WSO maintained a skin pattern. On DCS, the radar bit tests are not yet implemented, which should include the list shown below. Press spacebar to continue. WRCS bit checks, initiate. The AN/ASQ-91 Weapon Release Computer Set, WRCS, allows the F-4E to perform accurate level and dive munition delivery. The WRCS inputs are set by the WSO using the associated panels in the cockpit, and these inputs, along with INS data and radar target ranging, are used by the ballistic computer to provide the weapon release signal. On DCS, the WRCS bit tests are not yet implemented, but should include the ones listed below. Press spacebar to continue. Navigation computer mode, as desired. For this mission, set it to target 1, to fly towards our first waypoint. Altimeter and SPC, set and check. The static pressure compensator, SPC, is a regulating module within the air data computer used to eliminate major altimeter lag during rapid changes in altitude. The CADC switch, located on the front cockpit, controls the functioning of the SPC and can be manipulated by the pilot only. Set current altimeter setting on the barometric scale. For today's mission, it is 29.92 inches of mercury. On DCS, it is already set. The altimeter pointer should indicate the field elevation within ± 75 feet. We are currently at Bodo, which is at 42 feet above sea level. Press spacebar to continue. Prior to each flight, the SPC must be reset by the pilot. I will perform this reset now. After the SPC reset, the altimeter reading should not exceed 25 feet from the original reading, and it should indicate the field elevation within 90 feet. The difference between the front and rear cockpit should not exceed 75 feet. Press spacebar to continue. Wheel chocks and ground interphone cord removed. We have finalized the cold start and are now ready to taxi. I will ask the ground crew to remove the wheel chocks. Press spacebar once they have been removed.
Yes, sir. Chalk's out. Go get him, sir. Pew, 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 pew. Disconnecting.
Congratulations, you have successfully completed the WSO full cold start. On future training missions, we will study navigation and radar operation. Press spacebar to exit.